Yo, pseudo catalyst, but not in Fortnite, in IRL. Oh, scary. Well, technically we're in my basement, so we'll be alright. Anyway, today we will be tinkering with the ESP32. This little microcontroller is made by Espressive Systems. Has Wi-Fi capabilities. It's got these dual pin setups. As you can see here, it's the dev kit. It has a micro USB data and power port, a host of some LEDs, 2 buttons. It's just a very versatile little microcontroller. But today, we will be doing something very simple, and that is just making this little LED blink and pulse. So, we're going to make this blink and pulse, programming this, all connected through this. What is this? What is this thing? This is a breadboard. As you can see, there's a lot of holes. RIP trypophobia people. Ooh. These holes are all labeled, as you can see here. A through J, 1 through 65. The way these work is that 1A through E is connected like a wire. They're separated by this partition in the middle, and then 1J through F is connected like a wire. We can bridge this gap and connect these two together. However, 1A and 2A are not connected. Each set here is not inherently connected with each other. They are also inherently set, or rather I should say split, by this partition. And my breadboard also happens to have these extra little power running cables here on either side. So you can hook up a battery to the end and then have all sorts of power on the different lines here without having to use too many of these. But anyway, we will need more than just these 3 components. So for instance, we need these 2 jumper cables, male to male, and just a little 220 ohm resistor. And really that's it. Oh, and I should not forget, of course, a micro USB cable to power the ESP32 and to hook it up to our laptop to program it. So let's get started. We're going to take this dual pin system here and we're going to set it across the partition. I want to be working with this side of pins using the ground and the D2, so I'm going to leave space on this side. I'm going to make sure that everything is lined up well, that all pins are in. I'm just going to gently set that in there. We're going to take the black cable and we're going to connect it to the ground, like so. We're going to take the red cable, or the powered cable, and we're going to connect it to the D2. Now we will arbitrarily select a space on the breadboard. Let's say the long end here is the positive, so let's say we put the powered on 35 and the ground on 32. Now we're going to take the powered cable go across the partition here. We're going to take our 220 ohm resistor, we're going to bridge the partition with it. It's getting a little used. And we're going to take the black cable from ground and set it, my goodness, set it to the ground with the LED. That's really it. Ground to ground, power D2 to resistor to LED. Alright, now all that's left is to hook this up to the micro USB and boot up the Arduino IDE. So we have our ESP connected via micro USB. We've opened the Arduino IDE, and all that's left to do is to power the ESP32 and get it connected to the laptop. As you can see, I already have it pulsing. If you just wait a minute, you'll see that it shuts off. I've pre-programmed this. I just wanted to make sure that my coding was alright. Either way, I'll get back to you on a screen record walking you through the programming. So, here we are in the Arduino IDE. I already have my board recognized as a ESP dev model. If you have the ESP32 dev kit v1, just the ESP32 dev module on the USB port that you have it plugged into is what you're going to want to select. So we're going to delete this. Okay. So, line 1. Const int. Constant integer. We're going to name this LED pin. Capitalize that. And we're going to have that equal 2. Now, if you remember, I selected D2 for the red cable. And I'm not going to declare it as D2, just 2. So we'll add a note here. GPIO, pin, where LED is connected. Okay. So this line declares a constant integer, a variable named LED pin, and assigns it the value of 2, and this is the value of the GPIO pin on the ESP32 that our wire is connected to D2. So, if we hit setup, so we're saying that the LED pin, we're initializing the LED pin as an output. Let's just say that. Did I spell that right? I think so. So we're saying an output of data is going out of D2. So, pin mode, LED pin, output. So we have the setup function. This function runs once when the program starts. Inside it we have pin mode, the pin mode function, which sets the LED pin to output. This means we're configuring the D2 to send out voltage, which will control our LED. Okay. Void loop. So first we're going to do blinking, and then we're going to kind of tweak the code a little bit and do a phase in and out. So this is just going to turn the LED on. Digital wire. Ooh, I'm sorry. digitalWrite. So the LED is going to be set to high. We will wait for a second, and then we're going to turn the LED off. Oopsie. LED pin low, delay. Again, let's do a second. Alright. So here is our loop function all set out for ourselves. On, off, loop, on, off, loop, on, off, loop. Okay. First we use the digitalWrite to set the LED pin to high, which turns on the LED. And then the delay function makes it wait. And then we run the next set of lines, LED pin low, and then wait a second, and then back. It's looping to the high. That should be it. What we're going to do is we're now going to verify this. Are there any errors? And let us know. Of course. Oops. There we go. Let's verify that again. Okay. Now we're going to upload it. we go. The LED is flashing, and I'll get back to the camera and I'll show you the results. So as you can see here, the LED is now flashing on and off. So we got the LED to blink through the ESP32. But as you saw earlier in the video, I was able to get it to fade. I actually have another code here already set up. It's just a slightly tweaked edition of the last code. We can go through it right here. So the setup, the constant and the void setup, exactly the same, right? D2, LED pin output, but our void loop is different. So our loop function, this function runs over and over again, right? As we've seen with the last one. And the difference we have here is a for loop that gradually increases the brightness of the LED. It starts at 0, as you can see here, and then it goes up to 225. And then it loops, goes from 225 to 0. Okay, so I'll just upload that. And now I'll bring you right back to the camera. So, as you can see here, now the LED, if you just wait for it for a moment, will go down and slowly come back up in brightness. So, there it is. Thank you for joining me with this simple little microcontroller project. In the next video, we're going to be attaching a tiny little OLED screen. Alright, thanks for tuning in, guys.